Hello students, hope you are all fine. So now in this class I shall be discussing the addressing modes. So first question may be, what is addressing modes? So you know that whenever one instruction executes, then it requires operand to be operated on. Operands means data. Opcode means the instruction itself. So in case of addition, subtraction, they are the binary instructions. That means they require two data, say increment, decrement. There are some unary instructions. They require only one data to be operated. Now, how this data can be obtained? Let us suppose I want to pay 50 rupees to one of my friends. I can pay it by cash, or I can pay it by an account pay check. So he will drop the check in his bank to collect the money and fund transfer will take place. Or I can make the payment through self-checks. So he will be reaching to my branch and take the amount from that bank. I can make a payment by draft. So in different ways I can make payment to my friend. So this is known as payment modes. But here it is addressing modes. That is, how an instruction can be accessed, the operands to be operated on. So let me discuss them. Here I have done some categories of addressing modes. These categories are implicit addressing modes, immediate addressing modes, direct addressing modes, indirect addressing modes, resistor addressing modes, resistor indirect addressing modes, displacement addressing modes, and stack addressing modes. So in displacement addressing modes we have three categories: relative displacement addressing modes, base resistor displacement addressing modes, and indexing displacement addressing modes. So let me discuss these one by one. Now let me go for the implicit addressing modes. Implicit addressing modes. So what is the meaning of this term? Implicit. What is the meaning of this term? Implicit. So it means I am not mentioning explicitly, but inherently by default the instruction knows that from where it is supposed to access the operand. In case of implicit means I am not mentioning explicitly. Listen carefully. I am not mentioning explicitly. By default the instruction knows that from where it is supposed to access the operand. Let me give you one example. Let us take, say, CMA. Say CMA. CMA. What is CMA? That says complement accumulator. So this instruction CMA stands for complement accumulator. That is, whatever the current value in the accumulator will be replaced by its ones complement. So here we can see in this particular instruction I am not mentioning any operand. Is there any operand? No, na? Means I am not mentioning any operand. It knows that, or I can say it implicitly it knows that operand has to be accessed from the accumulator. This is known as implicit addressing modes. So this is implicit addressing modes. Next one is the immediate addressing mode. Next one is the immediate addressing modes. So what is the meaning of immediate addressing mode? I am telling you, in case of immediate addressing mode, the instruction itself will be having opcode. You can see in the board, in immediate addressing mode, instruction is there. So instruction consists of operand. So in this case, means in immediate addressing modes, the instruction itself will be having opcode. And another point is operands itself. That means there is no need to go here and there to access the operand. Instruction itself is containing the operand. Instruction itself containing the operand. Fine. So this is known as immediate addressing modes. So this will be an example of immediate addressing modes. Fine. Next is the direct addressing mode. Direct addressing mode. Here the instruction itself will be containing the opcode or the operation to be done, and in the rest part it will be containing the address of the memory location where the operand can be found. See here, address for direct addressing modes. The address will be referred at a location, or you can say a address location where I shall be getting my operand or data. Fine. Next one is my indirect addressing mode. So instruction is there containing the opcode, and it is containing the address. At this very particular address, like before, there is no operand, but the location is containing the address of the operand. So address of the operand has been kept. So it is known as indirect addressing modes. So in indirect addressing modes, you can see this is the case of indirect addressing modes. So the address is going in the memory. So from memory one operand is taking place. Fine. So means here, like before, there is no operand. You can see there is no operand, but the location is containing the address of the operand. Instruction has the address of the operand. So address of the operand has been kept. So it is known as indirect addressing mode. I don't know the phone number of Mr. X. Say, I am giving you one example that I don't know the phone number of Mr. X. So that's why I called Mr. Y, because Mr. Y knows the phone number of Mr. X. So that is the indirect addressing modes. Fine. So next one is my register addressing mode. Direct complete, indirect complete. Now we are going towards register addressing mode. Here what will happen? Here instruction will have the opcode and the register name. Each and every architecture is having set of registers, also known as register set. You can see here is the register addressing mode case. Fine. So these are different registers called the register set. So depending yes, now you can see now. Okay. So there are different registers called the registers means here instruction will have opcode and the register name. Each and every architecture is having set of registers and these are called as register set. So depending on the register number, one of the registers will be selected. I have selected one register R. Fine. I have selected one register, say for example R. So depending on the register number, one register will be selected by default automatically. So unique identification of the register can be done by the register name, which is mentioned in the instruction. So next is the register indirect mode. Register indirect addressing modes. It denotes that instruction itself containing the opcode and the register name. Where is the diagram of this register indirect addressing mode? Here you can see. So in register indirect addressing mode, the instruction itself containing the opcode and the register name. If you go to the particular register in the register set, each and every register in the register set will have a unique name. Say for example R1, R2, R3 or say AX, BX, CX registers, or in other microprocessor we are having EAX, EBX registers, whatever the names. So depending upon the register name, the corresponding register will be accessed. Like before, the register does not contain the operand. The register is containing the address of the operand. So this is my memory. This is my memory. Fine. Which is containing, memory is containing the operand at which address, the register address in which the register is containing like Mr. X and Mr. Y's example. Next one is the displacement addressing modes. Displacement addressing modes. Fine. So here is the displacement addressing modes. Fine. So here instruction is containing the opcode. It is having other two parts. One is having register number, other one is containing the address. So this register will be referred from the register set and register will get selected. Its content will be added with the address. You can see address is coming from here and the value of the register is coming from here. This will be added and it will be going to the memory. So its content will be added and the address, and then the address is form will be known as the physical address. means after adding the register value with the address we are getting will be known as the physical address. So obviously, where we will get the physical address? Here we will be getting the physical address. Fine. So, and that physical address will be mapped onto the memory to access the operand. This physical access, you can say, see, this physical access is mapped into the memory to access the operand. Fine. So here register containing one address, and this address will be added up to give the physical address which will be mapped onto the memory to access the operand. This is known as displacement addressing. This displacement addressing can be categorized into three categories I have mentioned earlier. In case of relative addressing, because in displacement addressing mode we have three types: relative, base register and indexing. Fine. So the register in case of in displacement addressing for relative displacement addressing, the register is a program counter. Register is a program counter. So whenever a register is a program counter, then it will be known as the relative displacement addressing mode. Base register addressing modes means this register will contain the base address, and this particular address will be offset or displacement from the base address. If you go on adding, you are getting the physical address to be mapped the data on the memory. So I am giving one example. Let us suppose the base address is 2000. This is our base address BA. The base address is 2000 and offset address say 20. So our base address is 2000 and offset address is 20. So if you go on adding, you will get what? The 2020. You will get 2020 as the physical address. So that your base register displacement addressing modes. In case of indexing, because the last case of the displacement is indexing displacement addressing modes. In case of indexing, this is a register containing the starting base address of the memory block, and this register is containing the index. Register containing the index. You know, in case of accessing a data from an array, we used A4, A5, A6. So what was A? That was the starting base address of the array. What was 4? What was 5? That was the index of this array. So if you go on adding the base address and the index, then you are getting the physical address. So same thing is happening here. Here A is containing the base address and R is containing the index values. Now adding, it will give you the physical address. Fine. Now last type of addressing mode is our stack addressing mode. Let us suppose stack addressing mode. Last type was stack addressing mode. Fine. So let us suppose we have an instruction called add. So where this add got to operands? It got to operands from the topmost two locations of the stack. So it is known as stack addressing mode. That is, any instruction knows that topmost one data if the instruction is unary, topmost two data if the instruction is binary will be the operands. So from where to get data? From the top of the stack. That is known as top of stack. So that is why it is stack addressing modes. Fine. So I hope you have understand the different types of addressing modes in 8085 microprocessor. See, if you have any doubt, you can write in the comment section, or also you can WhatsApp me. Fine. Thank you for listening. Thank you for watching.